Sketch the function f of x is equal to 2 to the power of x on given interval. So we're getting to the world of exponential functions. Anytime we have an x or the variable in the exponent, we are dealing with exponential functions. And we are just asked to sketch the graph, so a good start, if we don't have any clue what the function looks like, we can start with a table of values. So x, 2 to the power of x. And in order to know what the function looks like also for negative values, I will take negative 2 you can take like any inputs. I'm just taking some nice ones. 0, 1, 2. Let's say 3. So let's evaluate what's the value of the function for negative 2. I have 2 to the power of negative 2. Remember, now this number, this exponent is now given here by the first row. So this is 2 to the power of negative 2. I have a negative exponent. Anytime I see a negative exponent, I think of 1 over. So 1 over 2 squared, and that is equal to 1 over 4. 2 to the power of negative 1, again negative exponent, I think 1 over 2 to the power of 1, that's just 1/2. 2 to the power of 0, so anything to the power of 0 is just 1. 2 to the first power, that's just 2. 2 squared is 4. 2 cubed is 8. 2 times 2 times 2. I will maybe try to highlight the answers here. So 1 over 4, 1 over 2. Hope I will not make it more messy than it already is. So 4 and 8. And now let's sketch the graph. I don't have any negative values. And can I have any negative value? Can I have any x that I would get a negative value? When I take a negative exponent, I get a fraction. The smaller exponent I get to the power of negative 100. It would still be 1 over 2 to the power of 100. So very, very close to 0, but still it would never be negative. It would never it would never reach 0. So that's one of the properties of exponential functions. And so we found the values for negative 2, negative 1, 0, 1, 2, 3. And the interval we are given is between negative 5 and 5. So I made it longer, x, y. And let's start by finding the outputs for the values here. So for negative 2, I have 1 over 4. So if this is my 1, I divide in half, half, half. So this is the value for negative 2. For negative 1, I have 1/2. 0, 1. 1, 2. 2, 4, 2, 4, 3, and now this will not fit, so if you in your diagrams try to make it all the way to 3 at least, so this will be, if this is 4, so somewhere here we'll have 8. And now it's hard to sketch or find the value here on the graph for -3, we can evaluate it as 2 to the power of -3 is 1 over 2 cubed, 1 over 8. If we continue to 2 to the power of -4, 1 over 2 to the 4th power, 1 over 16. You can see how small it gets. Yeah, this would be 1 over 32. So it would be very, very, very close to x-axis, but it would never reach 0. I'm trying to connect the points with a smooth curve. So I would continue for 3, 4, yeah, and 5. Yeah, 2 to the 5th power, that's just 32. So either make your graph like a different scale for x and y axes, or I think it's just enough for you to write the values here so that I know, or so that you know what the outputs are for 4 and 5. Yeah, that one of the properties of the exponential functions is that it starts like slowly, but then the increase is very, very rapid, and it starts increasing very fast, and it becomes very steep.